Alright, this is a brief lesson on working with square roots. And first we should probably define what a square root is. The square root of a number is a value that when you multiply it by itself gives that number. So, for example, the square root of 9 is asking what number multiplied by itself or times itself gives you 9. Well, the answer we know to this is 3, because 3 times 3 is 9. Now, what's more important, and this is pretty critical, is to understand that the square root symbol actually has a little 2 up above it. We just don't show that because the square root is so common. So it means the same thing. And this 2 has significance because if you think about 9, 9 can be written as 3 squared. And so when these two match, it's saying, the square root is asking, hey, what is multiplied times itself? The 2 here is saying, take 3 times itself. And so the answer is simply 3. And if we keep that in mind, it's going to help you a lot with working with variables as well. So for example, 16, we know the square root's 4, but it's a 4 squared. And so if we think of it that way, we can see again that this imaginary 2 that's right here matches that 2, and you get a 4. Okay. Square root of 36, that's a 6 squared. So what's multiplied times itself? 6 is. Okay. And keep in mind, certain things won't be possible with square roots. For example, if I ask for the square root of -9, I can't write that as 3 squared. I can't write it as the same thing times itself. It's going to be a -3 times a +3. And -3 and +3 are not the same number. So this thing does not have any solutions, or it's an imaginary number. It'd be 3i, but for right now we won't be working with imaginaries until a little bit later. So that's how we deal with, or that's what a square root means, and that's how we work with them. So let's look at another example here. 2 square root 49. Now it's important to understand this is a big 2. It's not the little 2 I was talking about earlier. It's not that little guy. This little guy is called the index of the root. And again, if it's a square root, it's not shown that it's a 2. But what this expression means, it means 2 times whatever the square root. I shouldn't put a 14 in there. I'm going to put 49 in there, just because we want to be able to take the square root of it. So I'm going to put a 49 in there. So this means 2 times the square root of 49, which we know 49 is a 7 squared. Again, that 2 and this little 2 out here match. So this is 2 times, and this expression right here is just a 7. So we get 14. So keep in mind when there's no symbol between the radical and a number out in front, it just means multiply 2 times whatever that's equal to. Here's another example of that, -5 root 100. The square root of 100 is 10, so this is 5 times 10, or -50. Alright, I'm looking for, trying to think of, we should cover these guys. So with this guy, square root of x squared. Again, because we've been observing that if that's 2, the answer is just x, because x is clearly taken times itself when you have an x squared. If I have an x to the 6th, we have to remember our laws of exponents. That's the same thing as an x cubed squared. That 2 matches the 2 out here, and so our answer is just x cubed. In other words, x cubed times x cubed is x to the 6th, so its square root is just x cubed. Let's do square root of x to the 4th. That's the square root of an x squared. That's squared. This 2 matches this 2, and so our answer is just x squared. Now finally we have to get into a few specific details that we haven't discussed yet, and that would be something like x to the 6th. Now, we already have seen that that's an x cubed squared, which is x cubed. However, there's a slight problem with that answer. And the logic behind it goes like this. X to the sixth is clearly a positive number. I don't care if x is -1. If you got 6 -1s multiplied together, you're going to get a positive number. If x is +2, you're going to have 6 positives multiplied together, you'll get a positive number. So I am taking the square root of a positive, and my answer should be positive. However, there is no guarantee that x cubed, my final answer, is a positive number. If x was -1 and I cube it, I get -1. But I have to get a positive answer. So I force my answer to be positive by putting it in absolute values. Okay? Now, the only time that you really have to worry about this is when you're taking even roots. And in this case, all of these roots are even. We're taking square roots. That's an even number. And when the exponent inside is even, because that forces it to be positive. So, for example, the square root of x to the 14th is x to the 7th. X to the 14th is going to be positive. X to the 7th could be either one, and I need to force it to be positive. This doesn't always occur. For example, square root of x to the 16th is, think of x to the 16th as an x to the 8th squared. So the answer is x to the 8th. I'm guaranteed x to the 16th is positive. I'm also guaranteed x to the 8th is positive because of that even exponent. Even if x was a negative number, I have an even number of them, which will make it positive. So I don't need to put the absolute values around x to the 8th. It's already going to be positive. And I think that should get you through your assignment. Hopefully that helps. I'll do another one on fractions and simplifying those at a later date.